Hey students, this is lesson 9-7, tessellations. In this lesson, we are going to identify figures that tessellate and to identify transformations and symmetries in tessellations. Go ahead and do the review. The important definition there is what a tessellation is. All right, so a tessellation, by definition, is a repeated pattern of figures that completely covers a plane without gaps or overlaps. So what we're going to do here is just try and figure out what object is creating this tessellation. So what object is creating the repeated pattern of figures that completely covers a plane without gaps or overlaps. And if you look closely here, it isn't just this octagon. That octagon by itself would leave gaps, so it's the octagon and the square together that make the tessellation. So, and the transformation is, if you just slide that over, you get the next part. So this is a translation. All right, go ahead, you try that. All right, to help us determine whether a figure tessellates, one thing we could do is we could copy the figure, and then we could take those copies and see if we could maybe turn them and get it to tessellate that way. But there is another way we can do it. So, and you can see here that I get kind of stuck here. I end up with a gap there. And so, and if you look closely, what we need is 360 degrees of angles put together. So what I'm going to do is find the angle of each measure of this pentagon, and that's 540 degrees in every pentagon divided by 5, which is 108. Okay. And then if I take 360 divided by 108, I end up with 3.3 repeating, and for it to tessellate, this number would have to be a whole number. So the angles together must combine to equal 360 degrees. Exactly, in order to tessellate. All right, and you can see in this one, we're a little bit short of that, and so we end up with gaps. All right, you try that. All right, so what types of symmetry do we have here? And these are the types of symmetry that you're going to be looking for. Glide reflectional, rotational, and translational. I'm going to write those down. Okay, so glide reflectional symmetry is when the figure maps onto itself after a translation and a reflection. So if you think about this figure and we move it and then flip it, will it land on itself? So if I slide this over and then flip it, notice that it lands right on itself. So this one does have glide reflectional, so let's check by that. Now reflectional, that just means that a line of symmetry divides the figure into two congruent halves. So can I draw a line somewhere on that figure that will divide it into two congruent halves? So let's think about that spot right there. If I flip that spot over, will it be in the same spot? Will it match up perfectly? And yes, it does. So this has reflectional also. Rotational is when the figure maps onto itself after a turn. So if I rotate it, with that arrow, if I rotate this figure, will it map onto itself after a turn? And yeah, there it is. That matches onto itself, so it does have rotational. And then translational is a figure is its own image after moving a given distance. So if I take this original figure and move it a given distance, will I land on the same figure again? And you can see that that's true also for this one. So this one has all these symmetries. Go ahead, you try that. All right, here's a lesson check. Go ahead and do that and be ready to talk about that next time we meet in class.